Hello, this is Chris Chappa, and I am here to show you the solution to the third weekly logic puzzle during Math Month. This is what's known as a killer Sudoku, which is like a regular Sudoku, except there are also cells indicated by dashed lines around a group of squares. And the numbers in those cells must add up, or cage, if you will. The numbers in those cage must add up to whatever number is in the upper left-hand corner. For example, the three numbers right here would have to add up to 8. All right, and in the puzzle, I gave the hint that the sum from 1 through 6 is 21, which is critical when you're doing a killer Sudoku, especially when no numbers are given, because that tells you that every row, every column, every 2x3 rectangle adds up to 21. And we can take advantage of that in places such as the lower right rectangle, where we have this 14 here and this 11. The reason we can take advantage of that is because we know that all 6 of these have to add up to 21. So if I know the sum of the squares highlighted in yellow and then subtract 21, that will give me the number that goes right here. So let's figure out what the ones highlighted in yellow add up to. That's actually pretty easy. These add up, well, they're not yellow right now. Let's try that again. Yellow, please. All right. The ones in here add up to 14. The ones in here add up to 11. And so if we add those up, we get 14 plus 11 is 25. But we know that these 6 cells have to add up to 21. So if we subtract 21 from 25, that gives us 4, and that tells us that 4 must be in this square here. All right. Let's see if we can play that game anywhere else. We can, because now we know what all of these would add up to. We know what all of those would add up to because we know that these add up to 9, these add up to 11, these add up to 3, and we know this individual cell is 4. So let's find the sum of all those real quick. Let's see, 9 plus 11 plus 3 plus the stray 4. 9 and 11 is 20, plus 7 is 27. So we know those 7 squares add up to 27. However, oops, this is to be erased. However, these squares only add up to 21. So those 6 squares that add up to 21 plus this 1 square brings the total to 27. So if we subtract 21 from 27, we get 6 as being the number in this square right here. Now, this is not the only approach that you can take. There's several approaches that you can take, but I always look for places where I can take advantage of the sum. For example, in the upper right corner, these 6 squares add up to 21. However, these 5 squares add up to 15. So 21 minus 15 is 6, which tells me that the unhighlighted square in the upper right rectangle must be 6. At any point, we can shift gears. For example, this cage adds up to 7, and one of the numbers is 6, which means the other number in that cage has to be a 1. Is there anywhere else we can take advantage of cages? Yes. This cage adds up to 9. It's already got a 6 in it, so the other number must be a 3. Okay. Is there anywhere else we can take advantage of the fact that the sum is 21? Yes, in the first column. This first column has to add up to 21. But I know that these 3 add up to 10, and these 2 add up to 9. So together, those add up to 19. And if I take 19 away from 21, that leaves 2 to go right here. And in that cage where I just put the 2, it adds up to 3, which means the other cell in that cage has to be a 1. Okay, where else can we take advantage of the 21s? I'm looking from three perspectives: rows, don't see any places there; columns, don't really see any places there; and 2x3 rectangles. I think we've already taken advantage of all of those. All right, so now what can we do? Well, we can try some process of elimination in some cages where we know some but not all of it. For example, in the cage with the 4 that adds up to 11, we know that the total has to be 11, and there's already a 4 in there. 11 minus 4 is 7, which means the two numbers remaining in that cage must add up to 7. They can't be 1 and 6 because 1 and 6 are already in that column. Nor can they be 3 and 4 because I believe it mentions that no number can be repeated in any cage. So in that blue cage, there's already a 4, so I can't use a 4 again. So to get 7 for these two, I can't use 6 and 1. I can't use 3 and 4. I can only use 2 and 5. But there's already a 2 in the bottom row, which means if I'm going to use 2 and 5, the 2 has to be there and the 5 has to be below it. And now we're done with that cage. All right, let's see if there's anything else we can take advantage of. I got a couple more tricks up my sleeve that I'm not ready to pull out yet, but I think I'm about to unleash one. We know that every column, that won't work, never mind. I was going to say we know that every column adds up to 21, so any 2 columns adds up to 42. What I was about to say is these columns add up to 42, and then, but I can also add up these cages. This cage, this cage, this cage, this cage, and this cage, except that last one isn't a cage. I missed the square over here to the right of it. If it weren't there, then I would know that everything circled I could find by adding up the numbers representing their cages and then subtract 42, except I missaw it because, as I mentioned, this cage here does actually spill over into that column as well. So that didn't work. All right, so let's do Sudoku, because right now we're just adding stuff up. In the 4th column right here, and I'm winging this, I don't know if this is the best approach to this particular problem. We're missing a 3 and a 4, which means we know that there's either a 3 or a 4 here, or a 3 or a 4 here. Now that alone is not enough information to set anything off, but it is, kinda. I'm focusing on this 7 right here. That 7 can either be 1 and 6, 2 and 5, or 3 and 4. It can't be 1 and 6 because there's already a 6 in that rectangle up there. But it can't be 3 and 4 either, because if there were a 3 and a 4 here, then that would kill everything in that square. And the only thing that can be in that square is a 3 or a 4. So that means that these two squares have to be a 2 and a 5. I just don't know which is which yet. And that also means that the remaining 2 squares have to be a 1, 3, or 4. So that doesn't really help much. I just know this is 1, 3, and 4 to make the 8 in that cage. All right, let's see if we can figure out anything else. Sometimes you have no choices on sums. If you have 2 numbers that add up really small or really big, for example, to add 2 numbers to get 3, it has to be 1 and 2. But on the other end of the spectrum, to add 2 numbers and get 11, your only choices are 6 and 5. And I know exactly which one is 6 and exactly which one is 5. The 5 has to be in the leftmost square right here. It can't be in the rightmost square because if you look right above it, there must be a 5 in here. Therefore, it prevents a 5 from being where there's currently a yellow circle. So in that sum that's 11, I must have a 5 here followed by a 6 on its right. All right. The cage with the 3 and the 4 in it that adds up to 9, I now know has to contain 2, 3, and 4 because it's the only numbers missing in that 2x3 rectangle. But I know the 2 has to be in the middle right here. Why? Because it can't be here. Why? Because of this cell up, this cage up here that must have a 2 in it. And we already know that, oops, did not mean to erase that. And we already know that this can't have a 2 in it. So I know that the 2 has to be right here. And next to it has to be a 3 and a 4. All right, looking in that row where I just wrote the 3, 4, looking in this row right here, there's a cage with nothing in it, but I've only got one choice. The only numbers missing from that row are 1 and 5, and the 5 has to be in the left part of that cage because of the 1 down here. Okay. Now let's look in the 11 cage right below it. It has to add up to 11, which means it's a 5 and a 6, but because of the 5 that I just wrote in right here, the 5 down here has to be on the right side of the cage and the 6 on the left side. So that 2x3 rectangle is completed now. Let's see if we can finish the bottom 2 rows. The very bottom row, we are missing a 3 and a 6, and there's a 6 here, which means I know where the 6 has to go in the bottom row, along with the 3. That completes the bottom row. Now let's focus on the second bottom row and see what's missing here. We're missing a 1 and a 4. And I'm not seeing any evidence that forces the 1 or the 4 to be in a particular location. But let's just go ahead and document that we got 1s and 4s here. Okay. Let's go to the second column and look at this cage of 6. There's only 2 ways to get 6, 1 and 5 or 2 and 4. It can't be 1 and 5 because both of those are already in that column. So the cage of 6 must be a 2 and a 4. But I don't have any evidence that says which is which, so we'll just drop 2 and 4 in there. However, that gives us more information about the second column. The second column, the only number it's not accounted for is 3, which means the 3 must be right here, and so the cage that 3 is in, the cage adds up to 9, means we must have a 6 there. And now because of the 3 that we just put right here, looking to the right in this cell, which could be only a 3 or a 4, I now know that it has to be a 4. And within that cage, that means I can erase the 2 4s, which means the 4 in this column must be down here, which means to the right of it is a 1. Okay. Let's see. Oh, and in the top row, we have a 3, which means that this cell here must contain a 1, which means the cell below it must contain a 3. Sorry for the bouncy screen. Every time I touch my screen with the stylus, it bounces on my laptop. All right. Does that give us anything else we can fill out? Not yet. Let's look in the third column in the cage of 5. Looking in that column, it must be a 2 and a 3, and looking across the rows, the 2 has to be on top and the 3 has to be on bottom. That's because of this 3 right here. And now that I dropped those 2s in, and that two in, looking across the second row, I know that this cell in the second row, second column has to be a 4, and I know the second row, 6th column has to be a 5. So above that has to be a 2. It's all going to come into play now. In the third row, second column, where it says 2, 4 right here, because we just put a 4 above it, that means it has to be a 2. And now everything else is just going to collapse. This 4 means that the number right here in the fourth row, fourth column has to be a 3. So fourth row, 6th column, completing that cell, has to be a 4. Guess I can erase the highlight up here. And now we just got to see what's missing in each of the top rows. In the top row, I'm missing a 5. In the second row, I'm missing a 1. I better be missing a 4 in the third row because that completes the cage of 10. If you would like a challenge, I'm going to recommend a place to go look. I'm going to show you where I find a lot of these puzzles. I don't know why, but I stumbled across this when I searched Slitherlink looking for some puzzles. And the very first link is a website called puzzleloop.com. And if you go there, this is where I got all the puzzles for this go around. There's a Slitherlink puzzle, which apparently I started 19 days ago and never submitted. There, it only took me 19 days to solve it. But if you scroll down, you'll see a lot of other puzzles, including killer Sudokus. So the killer Sudoku that I got was from here. There's one I did 21 days ago. But if you scroll down, you'll see scroll up, you'll see all types of variations. And I'm kind of curious what this special daily killer Sudoku is. This is a Sudoku X, which means the main diagonals should also contain the numbers 1 through 9. I'm not going to waste any time on this video trying to solve this. I just wanted to share the website with you, which was Puzzle. Oh, it was Puzzle Loop, but when I changed it, it went to Puzzle Killer Sudoku, which makes me wonder if there's a main puzzle page. What happens if I click here? I want to log in. Okay, apparently there's a separate page for each type of puzzle, but that's cool. But again, to get here, I searched Slitherlink, clicked the first link, took me to puzzle-loop.com. And then if you scroll down, you'll see a variety of other puzzles that you can try, including, there's a Kuromasu here from the first week. No, I got that somewhere else. But I invite you to go down the rabbit hole. You're going to have lots of fun.